Hello everyone and welcome to the fourth and final tutorial of this quick series. Final because from this point on I want you to ask me for tutorials. So this is an example. Today we will program a missile and a missile behavior, so expect this tutorial to be long. But at this point it's all about getting used to the functions and learning and what functions there are and what you can do with LUA and what you can't, because LUA is also limited. For example, you can't access information about where the AI wants to go, which is stupid if you ask me, but because there are ways around that, but there isn't a function to gain this information. So if your AI wants to achieve an altitude of 100 meters, there's no way for you to gain this information. Literally, no way. But you can at least sheath around and gain the information that the AI wants to increase altitude, so that it wants to go up or down. And you can basically transfer the PID drive of the up channel to the LUA box by using spin blocks. But it's kind of cheesy and might not be intended by the developers, but whatever. We all know that everything that is possible will be done, so why not? Go ahead and try to reach me on any way, Discord or comments on YouTube. If you somehow figure out my private phone number, you can also call me. Whatever, what you want, but somehow let me know what you're interested to build or what you would like to know, if it is possible, and I will try to set up a tutorial, maybe also multiple part if it's a complex solution, and I will explain it to you, and I will make it that you will be able to build it and adjust it to your personal needs. So today we are going to control this missile. So let me tell you at the very start, in order to control missiles, you'll need a LUA transmitter on every single launch pad, and you will need a LUA receiver inside the missile. They basically just have implemented that, so LUA missiles aren't that OP, but they are still pretty overpowered. So in order to write this code, we have to learn one final very important thing, and then we should know everything to actually do this. So it's not that difficult, as I told you. It's all about getting down to the functions that are there. So what I will explain to you right now is, let's call it statements. I actually don't know the term for that, but it's pretty straightforward. So you can create loops. As I told you, this function is already executed 40 times per second, but you can create sections which are then executed multiple times each time this function is called. And this is called a for loop, for example. So you just write for, and then you have to create to name any kind of index. So I will just call this missile pad. Missile pad. For missile pad, maybe call it missile pad index. For missile pad index, not just missile pad. For missile pad, and now we have to give it a start value, and I will call it 0. For missile pad equals 0, and now we have to define an upper limit. And just to explain this to you, let's set the upper limit to 6. And then we have to write do and an AND. And this will now be executed 6 times. 41, 46, and so on. And let me just show you what I mean by that. I will use the log function again. And I will just print missile pad. So we get an idea of what's happening here. And what you see now, it spams 1, 2, 3, 4, 5, and 6 into the chat. And to make this even more intuitive, I will also print the game time, so we can see that something is happening. And this might be a little bit too much for the moment, but just recognize that this is how you add more into the log function. This is how you add strings. So I will now add 2 times pressing the spacebar. I will add that to get game time. And yeah, now we can see that the numbers are indeed printed again and again. And we also see that the identical game time is printed 6 times in the shed each. So indeed, this function, this section right here, is executed 6 times per cycle of the update function. Okay, and yeah, what this does exactly? It sets missilepad equal 1, and then it runs this code. And if it reaches the end, it goes straight back up to this line, and it will set missilepad to 2, run this code again. When it reaches the end, it will go back again, do the same for missilepad equals 3, 4, 5, and 6. And this is the for loop. And this is the lower limit, and this is the upper limit for the index variable. You call it index because you have, yeah, it's just called index. Just deal with it. Okay. And we will need this because I want you to understand how to scale this up. Right now, we just have one single LUA transmitter and one launchpad, but there easily could be multiple rockets, and why would you just control one explosive rocket if you could have 2? So let's just crank this up a little bit and copy this rocket. Now we have 2. And yeah, now we basically have to control two rockets, and this is why we need a for loop, and I will show you. Because now you have to be smart. Now you have to know the functions, and I can tell you there is a section called missile guidance, and here you can get a LUA transreceiver count. So this will return the number of LUA transreceivers, and this will basically, this means that this will now return 2. So if I put this function where there was the 6 just previously, this will now run this for loop for missilepad equals 1 and missilepad equals 2, and then it will reach the upper limit. And this is what happens. Now we only have the 1 and the 2. Yeah, if I stop it, we can see that more clearly. 2 times the same game time, and the 1 and the 2. Perfect. If I add one more missilepad, I actually don't know if they have to be connected, so I don't think so. Yeah, now we have the 6 again. If I remove 1, there should be a 5. And there we go. Now it only goes to 5. 1, 2, 3, 4, and 5. So this is what this code does. Yeah, you need this, of course, to go through every single LUA transmitter, because a LUA transmitter has a specific ID. And I will show you that. So, missile guidance. And now we will check how to actually control a missile. And where is it? Should be a set function. Set LUA controlled missile aim point. This is the only thing you can tell a missile. You can't tell them. You can't regulate the thruster. You can't regulate the fins. You can't regulate the parts it uses, or you can't drop missiles if you're using a cluster missile. You can only control the aim point. This was different back in the past. In the good old days, they could do way more stuff with missiles. For example, you could change the cone for fragments. which means you could track the enemy and make the fragment spawn in the direction of the enemy, which with yeah, combined with proximity fuses, this would be just completely overpowered when used against quick air targets, because you just had to get close to it and could just shred it into pieces by aiming the fragments in its direction. So they removed that. So now you can only control the endpoint. And what we see in here, this function sets the endpoint of a missile, and in order to do so, it needs the LUA transceiver index. So basically from what launchpad this missile was fired from. It needs also a missile index, because there can be multiple missiles up in the air launched from one launchpad, right? You can just use regulators to increase the lifetime of a missile, so there could easily be 10 missiles up in the air for one launchpad, or maybe you're using the small launchpad, which has always 4 missiles. So you also have to use a missile index. So what launcher, because the transceiver is always connected to one launcher, what launcher and what missile, and then the coordinates x, y, and is that u, y? I don't remember, and z. And we will need this, of course, and we will need the LUA transceiver index and the missile index. And this is what we'll do now. So we will use the LUA controlled missile aimpoint. And just for the time being, I will set the coordinates to 0, 0, 0. Or maybe let's increase the altitude. The altitude is the middle part. I will comment this again for you. It's a vector 3. Or, not really. But x, y, z translates to right, up, forward, forward, up, right. This should be correct. And yeah, so up and right should be 0, and let's set this to 50 or something. Okay, and I will delete that because we won't need it anymore. I will also structurize my code by moving everything a little bit out, so we can easily see what's happening. Okay. So next we will have to actually give this an index, so we'll use missile pad and put it right in there. So now we will go through all the missile pads, but of course we don't have this variable defined. So we will now just create another for loop, and you might have guessed it, now we will call the variable missile index, because that's what we need. And now we have to go through all the missiles, and again this goes from 1 to the missiles which are in the air, and we should be able to get this information as well. Get LUA controlled missile count right here. So this will return the number of missiles with that LUA transceiver has communication link to. So basically how many missiles there are in the air, and we can put this in here. And of course this needs the LUA transceiver count, so index I mean, so we put missile pad in there. And now we need an AND as well. So there we have our 2 for functions. Now structurized. Okay, and yeah, this is actually already it. So I can apply this. I can also clear the log, and this is running. And those missiles should now be aiming. And I really hope that this is working. Let me add a thumper head. So this has no aim at all. And let me also enable this so we can see in what direction the missiles are heading. And then let me get a weapon controller. and that shoot those. And they are heading somewhere. I actually don't know why I can't see where they're aiming. Might be because they're not aiming at all. So let's try to figure out what's wrong. I forgot semicolons. And this is wrong. Missile pad. Somehow I feel like this isn't the reason why this isn't working. So you see, struggling is completely normal. Maybe the missile index starts from 0. So I just shifted this. Now it starts at 0 and will go until 0, because this will be 1, because there will be 1 missile in the air. -1 means that yeah, it goes 0. And advice: always put brackets around something like that. Yeah, now it works. And now you can also see the coordinates in the world, because this is 0, 0, 50. This is the very, very center of the map, at least it's not that way. It's right here. And yeah, this is coordinate 0, 0 and altitude 50. One missile didn't go there, didn't went there, because this should go from 0 to -1. It's just where the game starts counting. The game doesn't start counting at 1 with the missile pads, it starts counting at 0. So let's do this, apply changes, and now both missiles should be controlled. We need ammunition. And there we go. Now both missiles are aiming at this coordinate. And right here we are actually already done, because I believe that you are able to get the rest by yourself. But I will now explain how to modify this further, so this will actually go for the enemy. But I believe that you can do this yourself. Just check in the help section, check for functions that might help you out in the situation. And I believe that you can do this yourself. But now we'll explain you how to track an enemy. So what I'll do first, oh wait, I'll tell you one more thing, so you might be able to get it yourself easier. You need the vector3 object, the vector3 variable type for that. So let me tell you one more thing, and this is actually important, so I'll put it right here and mark it with the important color, which is green. This is very important, because if most things which we have to do with aiming, you will need vectors. So let me just explain this. Let's just name this variable vector, and this is the vector3 type, and now we can put in the coordinates. For example, 0, 100, and 0. Or let's use the same coordinate we used in the previous LUA box. So this is, I'll write it again. This is, this has to be a capital V. This is forward, up, right. This is the direction. Minus, of course, means down, for example. So this would be down 10 meters down. This is how vectors work. And vectors basically describe directions, but also coordinates. So what we could have done with the aim point. we could have written vector 3, vector 3, vector 3 dot x dot y dot z. This will just extract the 0. Yeah, the vector 3 dot x will extract the 0, the vector dot y will extract the 50, and the vector dot z will extract the 0. This is how you deal with vectors, and yeah, you define them by doing that. Or we could what we could also have done, we could have done something like this: vector dot x equals 0, which just means that this value would be set to 0. So vector is simplified just option to store 3 floats, because those can be floats, if you remember the different variable types. Yeah. So, okay. So much about vectors. Let's program that shit. So, what I'll do now, I will define a target. Let's call this just target. Yeah. And targets equals a vector 3. So a coordinate in our world. And I will 0, 100 and 0, just for example. So 50 meters higher than we did here. And I will then write target dot x dot z dot y dot z to transfer the information from here into there. And now I can set one target, and all missiles will go for that target. So let's apply that, and let's see if the missiles go higher now. And indeed they do. This must be altitude 100. Yeah, and as we see, it's aiming for 0, 0, and keep in mind that they are orientated differently. X and wait, are they? Am I stupid? This looked wrong to me. So it says that Y is 0. Should be 100 though, which is interesting. Maybe it just gives you the yeah, it might just give you the distance to the aim point. Right, this might be the case. So so much about that. So yeah, basically means distance to the aim point, not the actual position of the missile. Yeah, down there you can actually see the altitude. How again to forgot how to use the cursor, but yeah, there's the altitude stat, and it was just around 100. Can go back in the video and check for that. So this is actually going to right altitude. Now we just have to know where our AI is aiming at, and we have to stuff this information into this vector. So we go to enemy, I guess it is, and this has a lot of similarities to the inventory. And if you remember back to the days where you were completely new to From the Depths, you also didn't know where to find the steam engine parts again, and where is the medium boiler. It's also stuff you have to learn. Same goes for LUA. So I know that there's target information, and so you can get a lot of information about the target. And we need this, get target information. Then you can choose any mainframe on your craft, because different mainframes can have different targets. Yeah? You should know that. If you have two different AI systems on your craft, you can use the target prioritization card and make them target different enemies. For example, one AI mainframe which goes for light aircraft, and it controls the flag weaponry of your craft, and the other mainframe controls the primary weapon system. it's a typical setup for any type of battleship. And yeah, you can use the mainframe index, and mainframes from your craft have a different index, and they are fixed. So and then a target index. So the mainframe can also have multiple targets, which means the prioritization. So if there are 10 enemies, your mainframe has 10 targets and it tracks 10 enemies, but it will only shoot at the enemy with the highest priority. So a 0 means first mainframe, and target index 0 is also the first target. So and this is the target prioritization card is in use. 0 is the highest priority target. So what we will just do, we'll get target information, and of our first mainframe on our craft, 0, and also for the highest priority target. So now we have get target information. We will save that in, what to call that, target info, and now we have to extract the specific information about the target, because this returns a target info object, and this is exactly this. And we have a list of different stuff, and now we have to extract what we want, and this works similar to the vector, where we can extract x, y, and z coordinates, and we want to get the position in game world of target object, and this is just named position. So we write target info dot position, and this is a vector 3. So we can just do that. Target equals the position of the enemy. We won't need that anymore, and there we go. Why isn't it working? Oh, because use a double point and not a normal point. And it's still not working. Target info. Target info dot info. This is how we called it. Okay, still not working. Yeah, stupid me. Of course, like so. Target info dot position. This is our variable right here, and we want to get position out of it. It's spelled with a capital P. Expected near I. Oh, we're also missing this symbol up here. There we go. And this will also happen to you. What just happened to me, but you will. It will take you way longer to figure that out, because it took me way longer back in the past to figure that out. I can tell you so. Yeah, but now this is running, and let me save this, and let's get an AI mainframe. I will just position that on here. Maybe not color everything. AI mainframe, and then we won't need any weapon controller. At least I think so. Yeah, we won't need any weapon controller. And then we just need general detection. So something like this. And let me just use the camera gimbal tracker and some progressing cards. Okay, should be able to detect most enemies. Then let's make this stuff invulnerable. And yeah, I still have to fire these missiles manually, but this won't matter. And let's spawn in, you guessed it, a marauder, because what else would you want to destroy? Maybe a little bit closer, because the range of the missiles isn't that big. But there we go. We won't need any on-turn. Because, one-turn I mean, because, yeah, we have LUA. And let's shoot. And as you can see, the missiles go straight for the enemy. because this is where our AI sees the enemy. And just as a comparison, how this looks if you won't use LUA. Let me use the active radar seeker on this missile and no frag. Frag is over here. I'm a genius. And let's shoot them. We don't have to identify enemy or foe add-on, so this missile went for us for a moment. Yeah, this missile aims somewhere different. Let me actually add that identify enemy or foe add-on. And also let's add an on turn on this one. One turn, I mean. Okay, save vehicle. Reload faster. Yeah, now we have the LUA controlled missile right here, and this is the radar controlled missile. Yeah, and this is how you do that. And of course, you could now just add any more missiles because we use the for loops. So you don't have any fixed values in there, you can just use more launch pads and more LUA transceivers and go completely nuts with your missiles. Oh, let's actually use small missiles because why not? So I can also show you that it works for multiple missiles on one launch pad. So let's also get a staggered fire add-on and also identify enemy of foe add-on because we don't want to shoot ourselves. And then we just have to add the LUA transceiver somewhere, for example here, and that's it. Now we have to copy it to every other launch pad. Did I copy the correct thing? I did. Let's set this to weapon slot 2 and this to weapon slot 1. Save the craft. And let's shoot. As you can see, they all aim for the identical point right here, because this is the aim point of the enemy of the AI. And they will go right to the enemy AI. Yeah. Yeah, this is it. If you want to achieve more complex behavior for your missile, ask me in the comments. I can show you that as well. This is the basics of your. Of course, you can completely modify where the missile aims. You can make it circle around the enemy. You can make it fly above the enemy and then straight down on the enemy. It's all quite easy from this point. You can also, of course, just copy this code. Right? It's not that much. Quite simple if you understood how it works. The part you want to copy is others two for loops, so from here to here, right? This is the important part where you control the missile, and this is just you just have to know I have to give this part in the code a target, and it will go for that target. Good. If I use this line instead, my missiles will again go for 0, 100, 0. Even if there's an enemy around. So this will now just ignore the enemy and aim for this point in the world. And if I then change the code, for example, I could put 1000 right, well, yeah, 1000 right here. They will go somewhere else, right over there, because this is 1000 blocks away. And they won't make it. Yeah, but this is how you do this. Then, thank you for watching until the very end. And congratulations that you have made it until here. Because I can imagine that was a lot to focus on. And just take it easy, take it slow if you're struggling. And ask me out if I can help you. I'll definitely do so. I have the time for that as well. And Yeah, leave a like if this helped you out. Maybe tell me what I could do different. Maybe I'll get into cutting my videos because that definitely will help a lot with the structure at least. Let's see. Communicate. And thanks. Bye. Have a good one.